All right, today we're going to be talking about the Pythagorean theorem. So you should be able to follow along on your worksheet. This is section number 1. It should look like this. A reminder of the Pythagorean theorem is that a squared plus b squared equals c squared. And at the top, there should be a little description that says that Pythagoras was a person, and we give him credit for noticing a pattern between the side lengths and the areas of right triangles. And one thing that he did to help him see these patterns was to draw squares connected to all three sides of the right triangles. And then he noticed that the area of the two smaller squares added together is equal to the area of the largest square. And you can see this might look a little familiar because that's a tilted square, which we were exploring the other day. So we're going to do one of these together also to show you one strategy for finding the area of a tilted square. And then you're going to try some on your own in the other sections of this worksheet. And so here we have a right triangle, and then we have a table that we're going to fill out about what are the side lengths A, B, and C, and then what are the areas of the squares A, B, and C. So if you see, we have side length A, but we also have square A. So A and B are kind of easy. I probably could find the length of sides A and B right now, but let's focus on those squares. So square A has sides that are 3 units long. And just from knowing that, I could find the area of a square. The area of a square is the same as a rectangle, which is length times width. But what we know about squares is that the length and the width are actually the same. So sometimes we'll say length times width. Sometimes we'll also say side, since it's not really a different length and width, we'll say side times side, which is side squared. So that's kind of what that squared comes from, squares the shape. And so here, when we have a square with a side length of 3, that tells us that all the side lengths are 3 units long. And that tells me that my area is going to be 3 squared. So that squared means 3 times 3. The little 2 indicates how many threes there are, right? There's 2 threes and they're being multiplied together. And 3 times 3, which is 3 squared, is equal to 9. Units squared, we could do like square units or units squared like that. We can just leave it as 9 for now if you want, either way. And then let's look at B. B has sides that are 1, 2, 3, 4, 5, 6 units. So by counting one side, I know all 4 sides are 6 because it is a square and it told us it's a square. And so same thing, the area is going to be side squared. So 6 squared. And 6 squared is 6 times 6, which is 36. And now is for the hard part, which is the tilted square. Some of you have methods for finding the area of a tilted square. Some of you might not yet. One option that you can do is that you can take two adjacent, so two corners of the square that are next to each other like that, and you can make a right triangle between them, and then repeat that for all of the corners that are next to each other. So here, the next two corners, and I made a right triangle. So I'm just kind of tracing the path, kind of like when we find the slope. I'm going down and over from corner to corner. And if I do that, you'll see that it makes 4 equal sized right triangles and then a square in the middle. My square in the middle is 3 by 3, right? I can see the units. It is 9 units. The area of that square is 9 units. But the area of these triangles might be a little harder to find. I could do the area formula for a triangle, or I could do the area formula for a triangle, or I can take one of those triangles and imagine if I picked up that right triangle and I moved it over here and I put it side by side with my other right triangle. Since they're the same size, I should get one big rectangle, which is a lot easier to find the area of. And so since my triangles are 3 wide and 6 long, I should get a rectangle that is 1, 2, 3, 4, 5, 6 long, and 3 wide. And then I know, right, the area of a rectangle is length times width. So it should be 6 times 3, which is 18, the area of that rectangle there. And I can repeat that process over here to make another rectangle that is 18 square units. So that was one method that people were using to find the area of a tilted square, of just kind of reimagining it, rearranged. But now I have three separate areas. I have the area of these two triangles was 18. The area of these two triangles was another 18. And the area of the square in the middle, which was 9. So my area for the tilted square, which is C, square C, right? The area of square C is 18 plus another 18 plus 9 square units. And 8 plus 8 is 16, plus 9 is 25. So 5, carry the 2, 2, 4, 45. And so my area for square C is 45 square units, or U squared. And so now that we know the area of all three, I can find the side length. If I see that the area of square A is 9, and I want to know the side, well, there's only one number that when I multiply it by itself gives me 9, because I know it has to be the same number, because all sides of a square are the same size, right? And so another way we can find that number is doing the square root of 9 will give me 3. The square root is an operation that finds what number times itself gives me the number in the square root sign. So here you notice I'm kind of doing the opposite. To find the area, I do the side squared. And to find the side, I do the square root of the area. That's because squares and square roots are opposite operations, just like adding and subtracting are opposite operations and multiplying and dividing are opposite operations. This is just one different kind of opposite operation. So to find the side length of a square, I could do the square root of the area. So if I repeat that for B, my side length for B should be the square root of the area, which is 36. What number multiplied by itself gives me 36? It's 6. And we already know that's the side length, and I can prove it because I can count the sides of B. C is a little bit harder because there isn't a whole number that when I multiply it by itself gives me 45. So that's when I can use a calculator or my computer. I could also leave my final answer as just square root of 45. That's plenty. I can leave it there. That could be my final answer. The side length of C is equal to the square root of 45, whatever that is. If I put it in my calculator, I do get 6.7 rounded. So that's a great answer too. So the side length of C would be 6.7. So hopefully this just allows you to see the relationship between squares and square roots and gives you one idea for finding the area of a tilted square. So you can go ahead and try some more of these types of problems on your own. But if not, when I come back, we'll have all kinds of different strategies for finding the area and we'll talk much more about the Pythagorean theorem. But just today, do your best. Good luck.